In this section, we're going to be covering section 3.4, which deals with optimization problems. Optimization deals with problems that you're going to be maximizing either the area or the volume of a particular object, or minimizing the area or volume of a particular object, or it deals with these maximizing or minimizing problems. So hence the name optimization, to optimize. So let's look at the first problem here. We have a rectangular box is to be made from a piece of cardboard 24 inches long and 9 inches wide by cutting out identical squares from the four corners and turning up the sides as in figure 1. Find the dimensions of the box of maximum volume. What is this volume? Okay, so basically we have this cardboard box and it's 24 inches by 9 inches, and each corner you got a square that's been cut out. Okay, and our goal here is to find the dimensions of the box as well as the volume of the box. So first, let's write down the formula for the dimensions of the box. So it's going to be the volume equals the length times the width times the height. Okay, so let's look at our shape here. So if we're going to cut out these four corners here and we fold up this cardboard at this dotted line, we are going to get this shape. Okay. All right. So first we need to figure out, okay, once we cut these corners out, what's going to be our length and width and height of this box? Well, if I cut these corners out here, right? And I know this whole thing is, this side here is 24, but I cut these two endpoints. So that means then this length here is going to be 24 minus 2x. Okay. And if I do the same thing for this right side of this box or this cardboard, right? I cut out the bottom of this side of the cardboard and also the top part here. All right, so I know this whole thing is 9. So if I cut those two corners out, this piece here is going to be 9 minus 2x. Okay, so let's transfer that information to this rectangular box. So I know the length here now is going to be 24 minus 2x, and the width here is going to be 9 minus 2x. Now, what about the height? What's the height going to be? Well, remember we folded this cardboard on the dotted line. So if we were to fold that up, the height is just going to be that x, okay? So height is x. So we have now the information that we need to plug into our volume formula. So we're going to have the volume is equal to the length, right? Which is this here. This is our width, and then this is our height. So it's going to be 24 minus 2x times 9 minus 2x times x. So when we multiply all that out, we are going to get 4x cubed minus 66x squared plus 216x. Okay. All right, so before we continue, we need to find out the domain or the area that we can work in, all right, the parameter. Okay, because if we are just kind of free range, then we're going to have a negative value, and we don't want that. So how do we find the parameter we're going to be looking at? So we need to use our graphing calculators to do that. So we're going to type this volume formula that we just derived into the graphing calculator, which I have already done. Okay, so try that again. Okay, so I already typed that information in on my Y1. So if I just hit zoom 6, it's not going to give me a very good graph. So I need to change my window so I can see my whole graph. So my window here, I have -2, 10 as my X min, X max, and I have -50 and 100 as my Y min and Y max. Now I can hit graph and I have something like this. Oh, I didn't get it all. So let's go back to here. Okay, that should have been 250, not 100 for my Y max. So 250. Okay, now let's try that again. Okay, much better. Okay, so again, we want the domain. So the starting, all right, of this graph and then where it's crossing the x-axis. Okay, so most likely the starting point is going to be 0, but let's just double check here. So in order to do that, I need to hit second trace and I want the 0, number 2. So I hit enter there and it's going to ask me for the left bound. So the left bound is just going to be below the x-axis. Okay, and we want it just a little bit below. Okay, the x-axis, and then the upper bound is going to be above the x-axis. So we want the positive there, about right there. Okay, and then this is going to ask us to guess. All right, so I'm going to guess about like right there. Okay, 0, 0, as I presume. Okay, so that's going to be the beginning of our domain, and then now we need to find that second 0 or that second x coordinate or x-intercept, I should say. So we go through the same process, hit second trace, and then we want number 2, 0. And now it's asking for the left bound, so that in this case, since we're looking at the right here, it's going to be above the x-axis. So how about right there? And then we want below, about right there. Okay, and then our guess is going to be it's somewhat in the middle. So, okay, so we found our other 0 or our other x-intercept or our domain now. It's going to go from 0 to 4.5. All right, so again, we don't want anything beyond that because again, as you can see from the graph, we're gonna go into the negative volume. We don't want that. Okay, so now we know what our parameter is or our domain. So that's going to be from 0 to 4.5. Okay. All right. Now we need to find our other critical point. So we found two critical points, 0, 4.5. We need to find another critical point. So how do we find the other critical point? Well, we need to take the derivative of this. So v prime. So this is going to give us 12x squared minus 132x plus 216 and equal that to 0. Well, notice that each one of these terms has a factor of 12. So I can factor out of 12 and I get x squared minus 11x plus 18 equals 0. Okay, and then let me break this down even further. This is going to break down to x minus 9 or factor to x minus 9 and x minus 2 equals 0. All right, so 12 equals 0. That doesn't make any sense. So x minus 9 equals 0, and then x minus 2 is equal to 0. So we get x equals 9 and x equals 2. Okay. All right, so we found the other critical points, 9 and 2. Now, as I mentioned, we can only be between 0 and 4.5. So that means then x equals 9, we're not going to use. Okay, so but we are going to use x equals 2. So in this case, our CPs, our critical points, are going to be 0, 2, and 4.5. Okay. All right, so now what do we do? Well, we're going to plug that information into our original volume equation, okay, to figure out which is going to give us the maximum value. So in this case, we'll have V of 0 is equal to 4 times 0 cube minus 66 0 square plus 216 times 0. For v of 2, that's going to be 4 times 2 cube minus 66 times 2 square plus 216 square. Then we have v of 4.5. So same thing, 4 times 4.5 cube minus 66 times 4.5 square plus 216 times 4.5. Okay. All right, so when we put this in the calculator, we're actually getting 0 for v of 0, and then 4.5, we're also going to get 0. Okay. However, for v of 2, when we enter that in the calculator, we're going to get 200 cubic inches here. Okay. So we found the volume of the box, which is, or the maximum volume of the box, which is 200 cubic inches. So now we need to find the dimensions of the box. And that's simple because we already found out what x is, right? X is 2. Okay. So we just need to plug in 2 for our length, width, and height formulas. So we're going to plug in 2 in here, plug 2 here, plug 2 there. So 24 minus 2 times 2, that is 4. So 24 minus 4, that's going to give us 20. This one here, 9. So 2 times 2 is 4. So 9 minus 4, that's going to give us 5. So this here is 5. And of course, this here is going to give us 2, right? Because x is equal to 2. Okay. So if we were to multiply those, volume, length times width times height, we're going to get 20 times 5 times 2. Okay. So that gives us also 200 cubic inches. So the work that we did does work out correctly. So in this case, the dimensions is 20 inches, okay, by 5 inches by 2 inches. That's the dimensions of the box. And then the volume of the box is going to be 200 cubic inches. So there's an answer there. Okay, let's look at the next example. We have a farmer that has 100 meters of wire fence with which he plans to build 2 identical adjacent pens as shown in the figure. What are the dimensions of the enclosure that has a maximum area? Okay. All right, so the first thing we need to do is write down our formula for the area. Okay, so in this case, let me pause here for a second. Okay, so we have the area of this shape is going to be base times height. Rewrite that. Base times height. So, okay. All right. So, what are we going to do here? Well, first, we need to find out, we need actually another formula here, and that's the perimeter. So, we need 2 types of formula. We need the area formula, and we also need the perimeter formula. So, let's go ahead and write that on this side. Okay. So we know that this enclosure is going to cover these areas, okay? So if this is X, this will be X, and this will also be X. And up here, if this is Y, then the bottom is going to be Y. So our perimeter in this case is going to be 3X plus 2Y, okay? Because again, this is a fence, and we have 2 identical adjacent pens, okay? All right. Do we know the perimeter? Yes. We're using 100 meters of wire fence. So let's go ahead and plug that in there. Okay. All right. Now we need to um, write down our other formula, right? We said it was the area is base times height. Then let's go ahead and write that down. So the base in this case is going to be y, okay? And then the height is going to be x, okay? So that's going to be our area. Y is times x. Do we know y? Well, we can find out, okay? So we need to use our perimeter here formula to find y. So we just need to solve for y here. So we're going to subtract 3x to both sides. And we get 100 minus 3x equals 2y. And then we're going to divide everything by 2. Okay? So that's going to give us 50 minus 3 half x equals y. Okay? All right. So we found out our y. So let's go ahead and plug that in. So we have 50 minus 3 half x, and then times x. So when we multiply that, we're going to get 50x minus 3 half x squared. Okay. So again, as before, we need to find out our parameter, the domain that we can work in. So let's go ahead and put that in the calculator. Okay, so I have here, I wrote down here my equation. Okay, so 50x minus 3 half x squared. Okay. Then I need to change the window. I have -5 as my minimum, 40 is my maximum, y min is -25, and y max is 500. All right, then I'm going to hit graph, and that's what we get there. Okay, so again, most likely this here where it's crossing or starting is 0. So I'm not going to worry about that right now. So, but in the homework and in the test, make sure you do, find out the exact value. But I've done it already, but this should be 0. Okay. Now we need to find out that x, the second x coordinate there, or x intercept. All right, so we're going to go to second, trace, go to 0, press enter. Okay, and what happened here? 2. All right, let's try it again. Second, trace, there we go. Okay, so we want to be above the x-axis. So let's get closer here. Let's hit the window here. Let's go. Let's make that lower. So let's say -100. Let's see if that helps us a little bit more. Okay, here we go. All right, so it gives me a little bit more wiggle room when I try to find that 0 over that x-intercept. So I'm gonna hit second trace again, go number 2, press enter. All right, I don't know why it's doing that. Try that again. Okay, so we're going to be above the x-axis. That's good enough. And then we want to be below the x-axis. It's good enough. And then we make an estimate. It's about right there. Okay, so it tells us that the domain is going to be from 0 to 33.3 repeating. Okay, now another way to write that is in fraction form, it will be 100 over 3. All right, so let me do that. Okay, so we're going to start at 0, and we're looking at 100 over 3. Okay. All right, so That's the domain or the parameter we are working in. So we found some critical points. And then now we need to find the other critical point, and that is by taking the derivative. So a prime. So that's going to give us 50 minus 3x. Okay, and we're going to set that equal to 0. Pause here for a second. Okay, so once we set that to equal to 0, then we're going to solve for x. So we're going to move the negative 3x to the right. We have 50 right over here. 50 is equal to 3x. Then divide by 3. Okay, so x gives us 50 over 3. All right, so that's the other critical point. All right, so now we found all of our critical points. So let's go ahead and figure out which is going to give us the maximum area. So we have a of 0, then a of 50 over 3. That looks terrible. Let's rewrite that. Okay, and then we have area of 100 over 3. Okay. When we put that in the calculator, we're going to get 0 for a 0, and then 0 for 100 over 3. And then for 50 over 3, we're going to get 416.67. Okay. All right. So in this case, then, the maximum area is this 416.67 square meters. Okay. So we found the maximum area. So the next part is we need to find the dimensions of this. All right, so we already know what x is. X is 50 over 3. All right, so we don't have to worry about that. Now we need to worry about y. Okay, so how do I find that? Well, we saw y here earlier, right? And we got 50 minus 3 of x. So I can just plug in, okay? Plug in this for my x. Okay? So when we do that, let me pause here for a second. Okay, so once we plug that in there, right? So at 50 over 3, we plug it in for our y equation, and we get 25 meters. Okay, so in this case, the dimensions of this square shape is going to be 50 over 3 meters by 25 meters. Or technically it's the other way around, so let me scratch that. It's going to be 25 meters times by 50 over 3 meters. Okay, so let's look at our last problem here. We have a rectangle that has 2 corners on the x-axis and the other 2 on the parabola y equals 14 minus x squared with y is greater than or equal to 0. What are the dimensions of the rectangle of this type with maximum area? Okay, so again, the first thing we need to write down is the area for this rectangle. So that's going to be, so again, base times the height. All right. So for our base here, if you notice on our graph here, so here's our parabola in blue, and then we have this rectangle underneath it. So this up here is x, so that means right here, right? This part here is also going to be x. Okay. Now we also have to consider or include the graph on the left side. So this is just a reflective image, so that means then this here is also going to be x. Okay, so in this case, our base is going to be 2x, and then our height, well, we know our height, right? it's y. And what is y? It's this one right there. So that's going to be 14 minus x squared. Okay, then we're going to distribute. So that's going to give us 28x minus 2x to the third power. Okay, so just like on the other ones, we need to figure out, all right, what my graph looks like. So y equals, okay, so disable that. We have 28x minus 2x cubed. Yep, this is it. Enter that. So this is what I want to highlight. And then we go to our window. Okay, so pause this here for a second. Okay, so here are my dimensions, or I should say the window of my graph. I got -5 and 5 are my x max, and then I have y min is -50 and y max is 50. So let's see what happens. So zoom. Actually, let's go back. Here we go. Okay, so that's what we get here. And so in this case, we just want the, again, quadrant 1, the positive domain. So this here, where it's going through the origin, that's going to be 0. And then we just need to find out where it crosses the x-axis in the first quadrant. So again, we're going to go to second, trace, and then go down to 0, and then make a guess estimate. Okay, here we go. So then we're going to enter for the right one. Okay, press enter again. And then we can make an educated guess. Press enter. Okay, so we get 3.7416574. So let's just round out to 3.74. Okay, so in this case, then our domain or the parameter we're working in is 0 and 3.74. Okay. So now we need to find the other critical point. These are the endpoints. So this is going to be A prime. So that's 28 minus 6x squared, and set that equal to 0. So we're going to get 28 equals 6x squared. Again, we're just moving that over to the right side. And then we're going to divide both sides by 6. Okay. And let's put that down here. So that's going to be reduced to what? 14 over 3. Okay, and then we're going to take the square root on both sides. Okay, so when we do that, we get about 2.16. All right, so now we found the other critical point, and now we're just going to plug this into the original function. Okay, so we're going to have a of 0, a of 3.74, and then a of 2.16. No, yes, 2.16. Okay, let me rewrite that. That looks terrible. Okay. Area, a of 0, a of 2.16, and then a of 3.74. Okay, so when we put that in the calculator, okay, a of 0 is going to give us 0, and A of 3.74 is also going to give us 0. And then for 2.6, when we put this in a calculator, we get 40.325. Okay. All right. So we found, so in this case, this is going to be the maximum area. Okay. But we also need to find here the dimensions of the rectangle. All right. So let's pause here for a second. Okay, so I'm going to plug in. So I got X is 2.16, so I'm going to plug that in here for my Y equation to find out what the Y value is. Okay, so um, so we plug 2.16 in there. We are going to get 9.3344. Okay, so the Y value is 9.3344. Okay. All right. So if we look here at this diagram, we have the area is going to be 2x because of here. Okay. Times that by y. All right. So 2 times x is 2.16. And then y is going to give us 9.3344. Okay, so when we multiply that, we're going to get 40.324. I'm sorry, 40.325. Okay, so the bottom line here are that we found the area, which is 40.325, and then our dimensions is going to be in this case is 2 times, right? 2 times of x. Okay, so let's pause this for a second. Okay, so as I mentioned, when we plug in 2.16 for 2x, so we're looking at this here. Okay, so we got area is equal to 2x, so that's going to be 2.16 times y. Okay, and that was going to be 9.3344. Okay, and that came from when we plugged in 2.16 for x for the y equals 14 minus x squared equation that we get here. So anyway, so we multiply those out. All right, so we get that again, the 40.325. But what we're looking for again was the base here. So let me backtrack. Sorry about that. So let's try that again. Okay, so the base is going to be 2 times x, so that's going to be 2 times 2.16. So that's going to give us 4.32. Okay, so the dimensions is going to be 4.32 by 9.3344. Okay, all right. And again, once we multiply that, we're going to get that 40.325 area.